Perfect. You're here. Come on in. Take a seat. Yeah. So, it's been a while since we last met. Hope classes are going well for you still. If I remember correctly, you have your first midterm for your intro to programming class next week. Is that right? Okay, yeah, thought so. Yeah, I would have liked to have a few more sessions before your test next week, but unfortunately both of our schedules just got so busy. At least we have this class today though, so we can review a little bit, just high level, what we did last session, and also, most importantly, go more into depth about the material that's going to be on your midterm next week. So we have a lot to cover. Are you ready to buckle down and get this review session started? Okay, good. I'm glad to hear that. So, let me pull up our notes from last session. Okay. So, let me see. Alright. Okay. So, firstly, do you remember the main topics we reviewed last time? Yes. Yes, that's really good. Wow. Yeah, so exactly what you said. We started with a look at what code can do at sort of the most basic level, such as mathematical operations, addition, subtraction, multiplication, as well as standard input and output abilities, C in and C out. Yes, exactly. We also looked very, very briefly at loops and what loops can do for us. So very simply, loops allow us to literally loop over a specific set of instructions for the program, and the ability to do this is really, really important to programming, because could you imagine, a human being having to copy and paste the repeated set of instructions over and over and over 100 times, 1,000 times, to do what a loop can do in 1 or 2 lines, right? So honestly, programming would be almost impractical and tedious without things like loops. very good. I'm really happy with how much you've actually retained and remembered. That's a really good sign. And the other major topic we looked at last time was variables. The concept of variables. Variables are such a foundational building block to programming, because if you don't have a way to name and describe objects and things, how can you do anything, right? If we didn't have words to describe different people, different organisms, different animals, how would anyone know what someone else is talking about? And it's sort of a similar concept with variables in programming. However, what we looked at last time was really only the tip of the iceberg, really just the surface. There's a lot more that will go into depth today, and this material will be pretty important because you should expect it to be on your midterm next week. So, right, let's talk about variables. Let's go. Let me pull up the editor. Okay. So really quick, brief test, if you will, of what we did last time. Can you tell me what it means to declare a variable, and what you need to do that? Right. Yeah, pretty much you got it right, exactly. A variable in C++ has a few requirements to be declared, and of course you cannot use a variable in C++ until you've declared it. So declaring a variable requires, one, a type for it, whether it's a number, and mind you, numbers have several different types in C++. You could be a whole number, which means you would be of type integer. You could be a decimal number, which means you could be of type double or type float. Those are both decimal numbers in C++. Or you could be a number that's always positive. It will never be negative. And then you could give it the type unsigned integer. The variations go on and on. But a lot of this stuff, a lot of these specific types, you can find the reference material online yourself. So sort of the basics that we need to know are, you need to declare a variable with a type of some sort, and then give the variable a name. And it's really as simple as that. Int x for an integer, and so on and so forth. So where this gets a little more complicated is what happens when you're using and trying to describe a thing or an object that is not so simple. Numbers and words and letters at the end of the day are pretty simple. They're sort of one-dimensional, if you will. A number is a number. And there's not much more to it than that. But what if you wanted to describe something more complicated? For example, a human being. Humans are so complicated. You could describe a human using his or her name, but you could also describe them using their gender, their ethnicity, their nationality, their height, their weight, their age. There's so many sort of facets to all of these different objects. And if you were, restricted to only being able to describe simple numbers and letters, you wouldn't get very far. So that's why in programming, you do have the ability to describe more complex variables and objects. And that is what we're going to talk about today. So sorry for my little spiel there. Hopefully I didn't lose you too much. I think things will be a little more easier to understand once we actually look at an example. So let me pull up the example that I wanted to go over today. Alright. So, complex objects. There are many instances where you would want to have the ability to describe and manipulate a complex object or data structure. C++ provides sort of two main tools to help you with this. They're called Structs and Classes. Structs and Classes. Using structs or classes, you can make your own method of describing and manipulating objects. So rather than describing or declaring an integer with the basic types such as int x or string y, you can instead declare it using the name that you gave your struct or class. So let's say we created one called my class. Right, so this is all, good and well. But then you actually have to go on and create this said class, my class. You have to create it and describe what does it mean, because otherwise the program doesn't know what my class is unless you tell it, okay, my class is this and this and this. And we'll get to that in a second. First, I want to give a little caveat. I'm telling you about structs and classes, and I'm telling you that they're both used to create some sort of object definition, type definition. But if you can use both of them, then why are there two at all? Why are there two different sort of concepts for being able to create an object type? Well, classes and structs are very, very similar. In fact, they are practically the same thing and serve the same purpose and can be used interchangeably. The only difference between them in C++ is that structs, they are by default public. What that means is what you define to be a struct is public and can be accessed by anything, anywhere else in your code. Your code can say, hey, struct, give me that one piece of information that's inside of you. That sounds funny, but that's what it means when, by default, structs have public member variables and properties. On the other hand, classes, by default, are public, which means when you create a class and you tell it you have all of this stuff and all of this information elsewhere in the code, you cannot request this information by directly accessing the private member variables or properties. You can, however, tell classes that you want some bits and pieces to be public, and you can likewise tell structs that you want some bits and pieces to be private. So you do have that flexibility and ability to customize, but it's good to just know the difference that by default structs are public and classes are private. And you can customize their internal workings however you like. Have a mixture of public and private members in both, and for all intents and purposes they function and serve the same utility. So now that we've gotten that out of the way, let's actually do something a little more concrete and tangible. Let's write our own class. So, as you see, I've created this my class name, and now we're going to actually tell the program what is my class, what is inside of it, and what are its members. So let's come up with a straightforward object type that has a little bit of complexity, but not too much. Any ideas? It's okay, don't worry. I know things are still kind of fuzzy and sort of amorphous because just explaining it really isn't enough, right? It really doesn't help that much. We have to actually see it in action. So a common example that's often used is the idea of shapes, right? Shapes are pretty simple for the most part, but they have a little bit of complexity because you can't just describe a shape with sort of one piece of information, right? You could call a shape a rectangle, and that would give you a decent amount of information because you know what a rectangle is, and you know it's different from triangles, circles, other shapes. You know there are a few things rectangles always have in common, and you kind of have a general picture in your head about what this rectangle is. But if I asked you to draw that rectangle, you would not necessarily be able to draw it correctly because you would not know how big that rectangle is, how fat or skinny or tall it is, how long it is, right? You wouldn't know its height and its width. You would have no idea, no information about how much area this rectangle has or its perimeter. But that's the kind of information that classes are made up of, the information that you can use to more specifically and more appropriately fully describe this rectangle and any other rectangles we want to manipulate and look at. So now that we have a sort of concrete example we want to start off with, we can try to implement it. So first, let's give our class a more appropriate name beyond just my class. Since we're going to be describing rectangles, let's call this rectangle. Appropriate. Let's change this back to rectangle. So here we're starting off with our class definition. What is a rectangle? What kind of information does a rectangle need for us to be able to describe it and manipulate it? So putting the word class in front here lets the system know that we are creating a class, which we are. So now inside these double brackets we can describe what goes inside of a rectangle, what pieces of information, what member variables and properties do we need to describe this rectangle. So we need things like its length, right? And its width. Those are the two most key pieces of information. So, for the sake of simplicity, I'm going to pretend that the length and the width can only be whole numbers, no decimals. So I can define its length and width using the method of defining variables that you use everywhere else. So int length, let's give it a descriptive name so we know length, what that means, what measurement that's referring to. And we need an int width. Alright, so remember what I said earlier. Classes by default are private, so everything inside is private. You cannot access this variable from the outside. You cannot say, hey, rectangle Z, what is your length? What is your width? You cannot here try to access its information because by default it's private. So let's just make it public then. Right? Like I said, you can customize and make anything public that you need. So, what can we do? There's a few things that we can do. We can create other ways of accessing this information, but that's beyond the concepts we're going to look at today. Instead, one of the simplest things you can do is actually declare or make some of the member variables public. Remember, we talked about how you can customize and there's flexibility in what's public and what's private, and you can mix and match. So let's make this information public simply by adding this public keyword. So now that we've made it public, we can access the rectangle's length and width. How? You can access class and struct members with the symbol period. Yeah, it's kind of strange. I'm not sure why, but you get used to it. So if we have rectangle C and a rectangle has these properties, length and width, tell me what Z's length and width are. We can do that by typing C dot length. And we declared Z as a rectangle, but no one's described Z yet, or its length and width. So we can do that right here. C dot length, let's set it equal to 6. We can also set its width to 2. And now Z knows it is a rectangle with a length of 6 and a width of 2. So that's really, really cool, because now anytime later in your program you can ask C for its information and it will know. You can say, hey, what's your length? And it will tell you. You can say, hey, what's your width? And it will tell you. And you can also change their values anytime that manipulation is necessary. So now we can do something even cooler. Classes are not restricted to only having member variables. They can have their own functions, sort of their own little pieces of code that do calculations. And once you've written it for the class, every instance of the class anywhere in your code will have the knowledge of that function and how to do it. So that's really helpful and pretty easy to do. So let's do that for our rectangle. What is a common function that shapes have? Right, yes, area and perimeter, exactly. So we can describe a function that will calculate the rectangle's area. Every instance of the class will have a unique length and width, so every rectangle will have a unique area. If it's able to calculate its own area based on knowledge of its own variables, then that is really, really cool for us and really convenient for us. So let's declare a function called area, and this function will calculate the area and spit it back out. It will give us back the area, which is a number, an integer to be specific. So you have to let the program know that this function will return an integer back to us. So what is the area? It is width times length. How do we give this information back? We say return the width times length. And now you can call the area function because we made it public. So you can call any rectangle's area function. Simple as that. Let's try cout.area. Let's put the end L there so it has a line break. And let's try running this. Okay, so this is to be expected. It's impossible to write code without having some kind of error or bug. So the first one at the bottom I already fixed. I had a semicolon here, even though that's not yet the end of the line. That was back when this line did not have this stuff at the end, so it had a semicolon there, and I just removed it. The other two are complaining that rectangle is not declared. The reason for this is most likely because the declaration for rectangle, which is this class, this description, needs to happen before we actually use it. That makes sense, right? In C++, the program executes from top to bottom, one line at a time, executing line 1 first, then line 2, then line 3, etc. So if it tries to execute rectangle Z before knowing what rectangle is, it will complain. So now let's fix that we've fixed that, and let's try running again. Okay, very nice. You see it spit out 2 numbers for us. That's because we see out twice. First one is the length, 6. That is correct. That is what we set the length to. Second number is the see out area. That also looks correct. The area of a rectangle with a length of 6 and a width of 2 is 12. Goes without saying. So very, very cool. So we can have hundreds more rectangles, or however many, whatever use case, and we can easily manipulate its length, width, and calculate its area. And this really, really is useful, especially when objects are much more complicated than the simple rectangle. Alright, so now we've seen a concrete example of the rectangle. Let's get a little bit more practice with, let's do one more shape. And this time you can help me with it. Let's try triangle. Okay? Sound good? Alright, great. So what's first? Right. We have to define what the triangle class is. Okay. Right. Member variables. How do you describe a triangle? Okay. And the most concise way to define a triangle is its width and its height. Right, there is also an additional layer of complexity in terms of, okay, what are its angles? Yes, but I think for now that's a little bit too complicated for us, so we're going to stick with the sort of oversimplified, but still works, width and height. So what do we need to do next? Okay, make it public. Exactly, so now this alone is a legitimate and usable class. We can come down here and define a triangle A, and that would work. But what if we also want to be able to calculate a triangle's area whenever we want? Okay, yes, let's make a member function. How would that go? Right, you return an int. Let's call it area, sure. Okay, yes, you return, and what do you return? Okay. Right, the equation for a triangle's area, which happens to be width times length divided by 2. Great. Now you can come down here and test it if you want, but I won't right now, just for the sake of time. It's pretty straightforward. You would do what we did with rectangle Z up here. What I want to talk about last thing today is a special kind of function, special kind of member function called a constructor. So we made this function area, and it is a member function inside of its class, and then you can make as many member functions as you need or want, but there is a special kind of member function called a constructor. And constructors are what their name sounds like. When you construct an instance of a class, right? You have to give it some information, like we did here. We gave our rectangle a length of 6, a width of 2, and we gave it all of that information. But this is a little bit tedious. You have to type all of this out. And what if your class has 10 member variables or 20 member variables? You don't want to have to do z dot a, z dot b, z dot c. Like, come on, no one wants to do that. And that's where constructors come in. It is a function that allows you to construct an instance of a class and at the same time, on the same line, initialize all of its values. So let's try that up here. We have to make it public again because we want to be able to access this constructor from anywhere in the code, because if it's not public and we can't use the constructor when creating the class, what is the point of it? So the constructor in C++ is always named the exact class name. So here, where we had the option of naming this area function anything we wanted, we could have named it hi. We could have named it area of rectangle. We could have named it anything we want, but a constructor must match its name. So, rectangle. That is the name. Great. A constructor is also special in that it doesn't return anything, so you don't need a return type the way that we put int for area here. So, rectangle, parentheses. Now the difference is here we left the parentheses blank. What actually goes inside of the parentheses are what we call function parameters. They are the bits and pieces of detail that the function needs to know to do all of its calculations and operations, right? For example, it might need to know certain numbers or certain facts to know what to do. And the key in constructors here is that constructors need parameters that are, can you guess? That are member variables. Does that make sense? So let me explain that in a little bit of a different way. We mentioned earlier that constructors not only allow you to create an instance of a class, it allows you to, on the same line, give values to your member variables. How do I know what values to give them unless the constructor receives parameters that tell it, hey, I would like to set the length to 6 and the width to 4. Otherwise, it doesn't know what you want to set those numbers to. It doesn't know, so it might just set it to any random number, or you won't be able to set it, right? So it receives parameters. Parameters are basically the same thing as variable declarations. They need a type. Remember, our length and width are integers, so our parameters, length and width, are also going to be integers. So let's get an int a and an int b. So now we've made the function take in two parameters, an integer called a and an integer called b. Now is the magic. We set these member variables to these parameters. So we've got set length equals a. Width, can you guess? Exactly, equals b. And there you go. Writing this constructor will save you from having to set the length and the width down here, because the constructor now has the code to do so inside of itself. And anytime you create a new instance of a rectangle using the constructor, it will save you from having to do this. So let's test our constructor, see if it works as expected. Let's delete where we set the length and width, and let's change how we define rectangle C. This is how we defined it before, but now we have a constructor that we can use, right? So how do you use the constructor? Same thing as before, rectangle, variable name, and now, hey, tell it the parameters it needs. It needs an integer and another integer. The first one will be assigned to length. The second one will be assigned to width. So let's put the length in first. We had a length of 6. Now let's give it the width, 2. Simple as that, one line. And everything else can stay the same. This creates for us a rectangle with a length of 6 and a width of 2. And now we can print this information to see if it's working as expected, to see if length really was set to 6, and to see if area is still 12, like it's supposed to be. So let's hit run, and now it's running. Okay, we received an error. classes need a semicolon at the end. My mistake. And this I incorrectly called length, but we actually named it height. Let's try again. We'll hit run again now that we've hopefully fixed all the errors, and perfect, voila, there you go. The length is 6, even though we never explicitly had to tell C dot length to be 6. And the area is 12, as it should be. So you can take this simple concept and make it very, very complicated and use it for many different complex classes and objects. And it's crucial that we have this ability and this concept of describing and manipulating objects and data structures, because the world around us is complicated, and to write code for a complicated world, data will also be complicated, and we need a way to break that down. So yeah, I think this is where we'll stop for today. That was a long session. Thanks for powering through. So I think if you review our notes from today again and last session, and some lecture notes, I think you should be really prepared, really good to go. So yeah, let's call it a day here. Good luck on your exam. I'm rooting for ya. And oh yeah, let me know if you have any questions or if anything comes up while you're reviewing throughout the next week. I'd be happy to give some more explanation or help you figure out a difficult issue. Alright, I'll see you next time, okay?